Welcome to episode 2, and this is our second episode in our Crossplane YouTube series. So let's go ahead and get started. The provider model. Providers extend Kubernetes API with cloud resources, similar to what we've seen with Terraform providers. We have the same idea here. The AWS provider adds over 1,000 resource types. Each resource becomes a Kubernetes object, and it's the same pattern with other cloud providers or even on-prem resources, so Azure, GCP, and so on. And then kubectl becomes your tool to interact with your infrastructure. So for example, kubectl get VPC will show you all your actual AWS VPCs. How does Crossplane manage resources? First off, you create a YAML manifest, then run kubectl apply, and then Crossplane will kick in, and it will go and create your AWS resources by talking to the AWS API. Crossplane continuously will monitor and reconcile your infrastructure and automatically detect and fix any drift that might happen. So if anyone makes a change in the AWS console itself, it will detect that and it will revert that change. What are we going to build in this demo? We have VPCs that we're going to create, subnets, internet gateway, route tables, and security groups. All will be managed through Kubernetes. We'll see the power of reconciliation in action. So drift is detected and fixed automatically. You don't have to do anything. Comparing this with traditional infrastructure as code tools like Terraform, you would need to run Terraform plan, run Terraform apply, and then hope no one changed it. With Crossplane, this is done for you out of the box with no manual interaction that you have to do. And this is thanks to Kubernetes internal reconciliation. So Crossplane is basically using that. So if you recall with Kubernetes, if you go in and delete a pod, if the pod is part of a deployment, for example, Kubernetes knows that your intent is to have this pod through the deployment. So the deployment will go back and recreate that pod you deleted. So it's the same idea now with infrastructure through Crossplane. So what are we going to demo? We're going to demo how to install AWS providers, how to configure secure authentication, how to create VPC and networking, and watching drift detection working in action. So let's go ahead and get started to build. But remember, at the end of this video, we're going to give you a sneak peek of what's to come in episode 3. Just a quick plug before we continue. This video is part of my Crossplane 101 course, where we dig much deeper into Crossplane and how to build your real internal developer platform. We cover Kubernetes cluster setup, AWS provider integration, compositions and XRDs, packaging and deployment, GitOps operations, Crossplane version 2 migration. And the course includes over 15 hours of video and 7 hands-on labs. You also get a certificate at the end, and you also have a 30-day money-back guarantee. If you're interested, check it out in the description below. All right, let's get back to our lesson. Here we go. We are in our Crossplane 101 course and in section 2 in the lab here, AWS Cloud Resources with Crossplane. I already started our lab for us so we can enter. And I actually also went ahead and skipped the first task here. As you can see, we have 4 tasks. So the first task was just to get everything set up. So I'll walk you through that real quickly. Step 1 is to verify the pre-configured Crossplane environment. So Crossplane, as I said, is a Kubernetes extension. So we can see the pods here running for Crossplane. That's all good. And also, if we go down here and look at the providers, you'll see we have 2 providers that are healthy, the AWS EC2 and the family AWS. That is what we're going to use. And to install it, we create a manifest like this. So you can see this manifest in the manifests tab here. We have the provider manifest right here, as you can see, of kind provider. And we also need to apply it. So you use kubectl to apply, just as you're used to. And then you can also see the CRDs that get generated. So if we run the command here, clear, you can see the different CRDs that are available here. As you can see, we can also or need to create the AWS credential secret, because this is how Crossplane is going to be able to access AWS. we can verify that the AWS configure list is available here. And this is part of the lab. When you start the lab, it will create an AWS account for you and will give you the secrets that you need to put in for Crossplane. And you can see here, create a secret containing your AWS credentials. So you can run this. We already ran it. So if you run kubectl get secrets, you should see the AWS secret here. You can also see the content, that decrypting it, and you can see both the key ID and secret access key right here. Then you need a provider config for authentication, right? So you need to tie the secret into this provider config. So once again, in the manifest, AWS provider config, you can see here we have our source is secret, namespace, Crossplane system, and then the AWS secret that we just created, applying that as well. And you can view the provider config, or you can describe it. Once again, the note here is to see how everything is done using Kubernetes, right? So if you're a Kubernetes shop, you'll feel right at home with Crossplane. So that was the first task. The second task was to test our providers and authentication. So we can create our first AWS resource, and that is simply by going to manifests, and we can copy this and create a new manifest, and we call this one test VPC .yaml. And let's go ahead and paste our manifest in here. As you can see, kind VPC, which is interesting because now we are using the extension, the CRDs from Crossplane, to create infrastructure. So we're creating a VPC in the region US East 1, the CIDR block right here in front of you, enable DNS host names and DNS support is true, a few tags, and then we're calling the provider config default that we just created. We can go ahead and apply that. So if you go back to the terminal and clear and run fly, that got created for us. And once again, you can run describe if you are interested in seeing this in action. Now we can go ahead and verify in the AWS console that the VPC got created. So the way we can do this is we can open the AWS console tab here, and we're going to need our username and password that was created for us. So if you click on open in AWS console, and then we just need this username, and then back here, it should give us our password, and put our password in place here and sign in. Just make sure that we're in the US East 1 region, because that's where we created that VPC. And now we can go ahead and search for VPC. And here we go. We got 2 VPCs, and we see our Crossplane test VPC right here with the CIDR block that we configured and the tags that we put in place, and all looks great. Now let's demonstrate Crossplane's reconciliation. So what we can do, we can select this Crossplane VPC and edit it, and then change the enable DNS host names to disable, and then save the changes. And then we'll see how this will get reverted and how Crossplane is going to bring it back. So edit VPC settings, enable DNS host names. Let's look into that. Edit, let's see, VPC settings, enable DNS host names. Let's remove that and then click save. And DNS host names is disabled. Now, if we wait a little bit, we'll see how this will bring us back, or Crossplane is going to bring it back. So I'll pause the video and wait for this to trigger, because it can take a little bit of time. But you can also run this command, and you should be able to see synced status briefly. We might be too late, but either way, we'll see in just a second or two how the Crossplane will revert back that setting that we changed outside of Crossplane. So we're simulating drift, basically. All right, I see some changes at the bottom here. Well, it looks good. So let's go into our, oh, there we go. Enable DNS host names is enabled now. And that is done automatically through Crossplane without having to figure out what has drifted and whatnot. This was all done for us. which really shows you the power of the reconciliation loop. Okay, and that should be good for this task. Let's move on to our next task, where we're going to create a VPC and networking infrastructure. So not just a VPC, we'll do a lot more than that. So first, let's clean up and review the infrastructure files. So you can easily run kubectl delete VPC, and then the VPC name that will remove our VPC. And we can verify that by going to, once again, our VPC dashboard here. And you can see if we refresh, there we go, it's gone. And we are back here. The setup script has already created all the necessary manifest files for us. Take a few minutes to review those. So if we go to manifest, you can see the setup script for this task has already created a bunch of configuration for us. So this was our test VPC that we saw earlier. We see some security groups now. You can see the resource kind here, security group. Okay. And we see another security group. And then these are some security group rules that match, use a match label to match the security group. And then we have an ingress rule for port 80 to port 80. Region is US East 1. Here's another web HTTPS ingress for port 443. Here's one for port 8080. We have some public subnets that got created as well, kind subnet. And you can see we have a selector for the VPC. So we need to attach the subnet to a particular VPC. So we're matching that by label, as you can see here. And here is, so that was public subnet. This is another second public subnet. And here are the private subnets. So we got 1, 2, and then we've got the platform VPC. This is the new VPC, not the test VPC. So this is a more advanced VPC, as you can see here. And then an internet gateway as well. So you can see the internet gateway. And once again, VPC ID selector, we're matching by label. So tying this internet gateway to the VPC that we created. And then, of course, the Ep2 provider and AWS ProviderConfig. So now we just need to deploy. So now that we've reviewed everything, we can go ahead and go back to our terminal and apply the VPC configuration. And notice we are going to apply and pretend that we are the platform team. So when this lab was set up, it was set up based on what we did in episode 1 with RBAC. So we have all the RBAC in place, which is what you need to do in production. So then when we're deploying the VPC in this case, we're deploying it as a platform admin, as part of the platform team. We can now wait for this VPC to be ready. Condition is met. Excellent. And notice now we're running kubectl get VPC and the name of the VPC, and we can see that it's synced and it's true. Again, we're using kubectl in our commands. And now we want to add internet connectivity, so we can run this command for the internet gateway, and we can wait for it as well. Okay, it's done. You can look it up. It looks good. And now we want to create the public subnets. So we'll run this command and we can wait for it. So that created subnet 1A and subnet 1B. We'll wait for them to be ready. Subnet 1A is ready. Let's check on subnet 1B. That one's also ready. And we can check the subnets using kubectl get subnets. Looks good to me. And then we can create the private subnets similar to what we did with the public subnets. And again, wait for them to be created. Subnet 1A is created and subnet 1B also. Now we can create security groups. Run this command. And we got 2 security groups created, so let's wait for them. This is the platform web and then the platform app. Perfect, they're both created. And now let's go ahead and look at step 7, where we are applying the security group rules that are tied to the security groups that we created. So that's the HTTP ingress, and it's done. Let's look at the HTTP HTTPS ingress, that's done. And then let's look at the web ingress. That's also complete. We can verify everything here with all these commands. We can also use this Crossplane beta trace command, which is one of my favorites. It will make a lot more sense when we use it with the compositions. In our next episode, we'll see that. But you can see that these are all synced and ready, which is great. And once again, we can jump into the AWS console, look at VPCs, subnets, internet gateway security groups. So let's go ahead and do that. So refresh the VPC, a new one should show up. There it is, platform VPC. As you can see, it's right here. And it has a bunch of subnets with routing table. And we also should have an internet gateway right here. There it is. And some route tables that we saw. And here are subnets, some public, some private. And then security groups. Here are our security groups, platform web, platform app. If you click on one of these, you can see it has HTTP and HTTPS rules. So that all looks great. And now we can just delete the work that we did. And once again, you can delete it with the kubectl delete command. That's pretty much what we'll probably be doing in the next task. So let's go ahead and do that. First, let's make sure that we did everything correctly, and we did. Now learn how to properly clean up all the AWS resources we created. So review the current infrastructure. You can use this handy command where you can run kubectl get VPC, subnet, internet gateway, everything in one command. It will show you everything at once. Now, before deleting resources, you need to understand the dependency order. So you can see here, this is the hierarchy. Always delete in reverse dependency order to avoid errors. So you can see security group rules, they depend on security groups. Security groups depend on VPC. Subnets depend on VPC. Internet gateway depends on VPC. And VPC is really the base resource, should be deleted last. Okay. So let's go ahead and start deleting. You can delete the security group rule. Make sure it's all deleted. And there it is. Delete the security groups. Let's delete all the security groups like that. And verify that it's gone. Delete network components. So all the subnets, the internet gateway. We can check on both. No resources. Looks good. Finally, we can go ahead and delete our VPC. And now if we run this command, it should show no resources found. Perfect. And if we check on all our resources in AWS, in the console, go ahead and refresh. There you go. VPC is done. It's gone. Routing tables, these are the default ones. So our routing tables are gone. Subnets, let's refresh. These are gone as well. Internet gateway, refresh. That is also gone. Good work. So that pretty much concludes our demo. And again, we were able to create the resources in AWS using Crossplane. And we saw how we're able to make use of the reconciliation loop. And we saw drift detection being reconciled automatically. In our next episode called Developer Self-Service, we're going to build platform abstractions. We're going to see how to create custom APIs for developers, how one claim can create 13 AWS resources. Claims, by the way, are for version 1.x of Crossplane. At the end of these episodes, we're going to talk about version 2, but bear with me in case you at your organization are still using version 1. So that's why we have this. And then also abstractions will hide complexity and maintain power. So episode 3, wait for it, the magic of compositions that will give us that developer self-service. Once again, if you want hands-on practice, do check out the Crossplane 101 course. Link is in the description. Thank you for watching, and I'll see you in episode 3.